Okay, so hello. I'm really excited about being here in person, delivering a talk to actual people that are sitting in front of me, because I haven't done that since before the pandemic. And I've been dreaming about it for a long time because I really like doing talks, and I've done a lot of online talks, and it's frustrating because I can't see the audience. So it's great to be here. So I am going to be talking about how to stop testing and break your code base. My name is Clare Sudbery. I am a lead engineer at Made Tech. We are a small consultancy. What we specialise in is helping our clients, who are mostly public sector, with their software delivery. So I'm going to tell you a confessional story. It starts out happy. The protagonist has a quest. They're excited, they're reaching their goal, but then disaster strikes. So the question is, how do they overcome adversity? What do they learn along the way? And what can you learn from their journey? So the story has a happy ending, and the protagonist is me, as you might have guessed. And the quest is to create a new iOS app, which is a game. And the disaster comes because the tests are woefully inadequate, and the lessons learnt are to make the most of TDD and pairing. So because they really do make a difference. Okay, but before I carry on, I just want to find out a little bit about the audience so that I know who I'm pitching this to. So it is a story about TDD, which stands for test-driven development. So I've already given away a little clue. Can I just have hands up if you know what TDD is? Okay, so that is pretty much everybody. Does anybody want to have a go at describing what it is? Anyone want to give me a definition for what is test-driven development? Is everybody too shy? Go on.
So rather than going in and writing your code, write the tests, and from the outside control how your unit is going to interact with the outside world, and then go and implement it. And ideally, a bit of test, passing, and build up that way.
Okay, so in case people didn't hear that, the description was, forgive me if I don't get exactly what you said, but that you are using tests to design your code. You're going from the outside in. You're using your tests to describe what each unit of code will do, and then hopefully as you go along, you're making those tests pass. So a really common way of describing it is that you go through a little cycle. You write a test, you see the test fail, which is a really important part of it, because then when you make it pass, by implementing the code that will make it pass, you know that it was your code that made it pass, because it's actually quite common to write tests that pass for the wrong reasons. So you want to see it fail, so that you know that when you implement the code, it's passing because of your code. And you deliberately write tests before code, so that the tests themselves are defining the behavior of the system and defining the expectations of the system, and then you are constantly proving that you're making the system behave as it should. So that's, in a nutshell, what test-driven development is. And before I leap in, I just want you to have a bit of a think about, see if you can think of 2 reasons in favour of test-driven development, so 2 reasons why test-driven development is a good thing, and 2 reasons why it isn't. You can collaborate. It would be nice if you collaborated with your neighbours, but I don't want to force you to talk to people if you're shy. So if you want to collaborate with the person sitting next to you, that would be great. If you don't, you don't have to. So I'm just going to give you a minute to think if you can think of 2 reasons in favour of TDD and 2 reasons against it. Feel free to join us. Okay, so I'm not going to ask you to share those yet. If you can find a way of making a note so that you remember at the end on phones, you probably don't have much paper, but if you can find a way of making a note, or just if you've got good memories, try to remember what those 4 things were. Okay, so this is Squarefill. Squarefill is the iOS app which I created. It is a game, and this was my quest. And this was a long ambition for me. I have an iPhone, and I'd always wanted to write my own app. And I particularly, personally, enjoy playing games like that. So my phone is absolutely full of very simple little puzzle games that involve moving shapes around on a screen. I believe there's been research done that it actually, like Tetris, games like Tetris release endorphins. I particularly respond well to those kind of games, so I really like the idea of writing one for myself. And a very quick description of how the game works. It's very simple. The hope was that in future, and the hope still is, that in future iterations there will be more complexity, but as it stands, what happens is when the game starts, all of those pieces that are currently in the black grid are at the bottom of the screen and they are shuffled, and your job is to make the rainbow pattern in the top grid by sliding the pieces into place. And the pieces, it's quite important that the pieces cannot move over each other. They can only move around each other. So although it's a 2D representation, it mimics a 3D world that you can't just fly over the top, you have to go around. And very quickly, the game became not just to play the game for me also became to write the code, and the game also became to keep up with my own desire for new features. So I understandably quickly got quite good at playing the game, and I wanted the game to get harder and more challenging. I wanted there to be more levels, and I was quite a demanding stakeholder. I wanted those things now, and I didn't want to have to wait. And also this was compounded by the fact that I was coding this in my spare time, so I was doing it late at night after the kids had gone to bed. I was doing it at weekends. I was doing it not according to sensible working hours. So I was often already a bit compromised and tired, even when I first sat down to write the code. So it became very easy to make bad decisions. And so although the game of writing the game I was doing okay at, the game of writing good code I wasn't doing so well at. So because I was impatient and I was in a rush, I decided in my wisdom that I only really needed acceptance tests, that I didn't really need unit tests. So when I say acceptance test, I mean tests that just describe the user's view of the system, describe how the pieces are going to move around on the screen and what the user is going to see, but the tests themselves aren't testing individual units of code. They aren't testing the deep logic. They're just describing what the user should see. So I mostly wrote acceptance tests, and I didn't write very many unit tests. And I thought, this is great. This is speeding me up. This is a good idea. Everybody should do it like this. And now I can't believe that I did that, but I did, and I have to own up to it. Okay. So I was like, yeah, up yours. I don't need tests. But then it all went wrong. So the question is, what went wrong? And there were lots of areas where I experienced pain as a result of my lack of tests. And as time went on and I wrote more and more code, I experienced more and more of this pain. And in the end, I ground to a halt, and I had to really stop and rethink what I was doing. So what I'm going to do is I'm just going to describe the pain that I experienced. And I'm going to describe the different areas that I struggled with. So the first one is encapsulation. So let me explain what I mean by encapsulation. This is a quote from Martin Fowler. The essence of encapsulation is turning a design decision into a secret. So the idea there is that your classes, your units of code, will contain implementation inside them that the clients of that code don't need to know about. The clients know what the code is supposed to do, but they don't need to know how it does it. So that's the idea of a design decision being a secret that isn't visible from the outside. Another thing that he talks about is that modules of code, so for instance a class, should be arranged around system secrets. So each module is hiding its secret from the other modules. And then if the secret thing changes, so if the implementation changes and you change your mind about how you're going to do something, nobody else is affected because they don't even know about it. So the clients of that class, the other modules of code, don't know about it. So this is encapsulation. Now, my acceptance tests did not help me with encapsulation. So what this is showing you here is that I had acceptance tests that said that at the beginning of each game, what would happen is the user would actually see that first view on the left, and then they would see an empty grid, and then they would see all of the pieces that had been taken out the first view, shuffled, rearranged at the bottom. And every time you play a new level, even though the pattern remains the same, the pieces change. And also the shuffling of them changes. So it becomes a different puzzle every time. And what the acceptance test said was simply that this is what a user should see. What the acceptance test didn't tell me was anything about what was happening underneath that. So underneath that, messages are being sent back and forth between different classes. Different classes are taking responsibility for different aspects of the logic. They all have their own responsibilities. And although that was expressed relatively well in the code, it wasn't expressed in the tests because those classes didn't have tests around them. So therefore, there was nothing enforcing that encapsulation. So, and I was trying to save time, but it meant that there was nothing in the system that said that the various different bits of logic should be encapsulated. It was just kind of look if it happened. So that was my first problem. That was encapsulation. So the next one I'm going to talk about is the single responsibility principle, which is the S of solid. I'm not going to go through all of solid, but you might well have heard of the SRP, and that's the idea that every class should have one single responsibility and that you should keep your classes or your units relatively small, and they should only be responsible for one thing. The problem that I had with that was, again, that my acceptance tests weren't telling me anything about how my code was encapsulated or what responsibility different elements of the code were taking. Because encapsulation on its own actually isn't enough. So you can encapsulate, which means that you create a kind of shell around the outside of your functionality, which is your interface, depending on what language you're using. Your interface is your contract with the rest of the world. You're saying this is what this unit of code should do. But you could encapsulate a lot of code all in one class, and you still wouldn't have a great design. So as well as encapsulation, you also want to take account of the single responsibility principle. Because I didn't have any tests, there was nothing that was enforcing or describing the way that those units of code were designed or were interacting. And the level of testing that you have will determine the level of encapsulation and single responsibility that is being enforced. And if you only have the high-level tests, you could easily end up with modules that are too large, and your tests are not helping you with that. Whereas if you're using really good TDD practices, what you can do is use your tests to document, clarify, and guide your design. So I will come on to that a bit more later. Okay, so we've covered encapsulation, we've covered single responsibility. The next thing that the test didn't help me with was the idea of public versus private. Now, this is going to depend what kind of programming paradigm you're using, but I was programming using Swift, which is very similar to C#. And in fact, I originally did code it in C#, and then I converted the code. I actually wrote a little script that converted C# into Swift because I decided that I wanted to do the native iOS implementation. And so the concept of interface still works in Swift. And therefore, you also have the idea of public and private methods. And Often when you start talking about encapsulation, you start thinking about what should be public, so what should be visible to the clients of your code, and what should be private. And tests can help you with that, because the test will always be testing the public interface. In fact, it's not possible in most languages, most object-oriented languages, to write a test of private code. It has to be public in order for you to test it. So the test can help you to make those decisions about what should be public and what should be private. But if you don't have tests at the unit level, then again, you've lost that benefit. And that meant that I did lose that benefit. And I will talk a little bit more about that later. So the next thing that I struggled with, and this is a big one, was debugging. So again, if we go back to before, you'll see that I had acceptance tests that defined this level of behavior, what the user saw. And then when there was a bug, which of course there were, because I'm human, when there were bugs, like for instance, I might find that I was getting a glitchy display, and maybe pieces were actually being able to move over each other when they should have been going around each other. Or one of the bugs I had was that small pieces weren't able to move between two other pieces in a kind of a channel. There were loads of bugs. But whenever a bug happened, I could detect that there was a bug because my acceptance tests would fail. But beyond that, I didn't know which class the bug was in. Because beyond this high-level view, I've got multiple classes interacting with each other in different ways. I don't have unit tests around those classes. So when something fails, I can't find where the failure is. Whereas if I had unit... Oh, okay. Is it going to come back? If I had unit-level tests, then I would see those unit tests failing, and I would be able to narrow down the problems much more quickly and easily. So the next thing that I struggled with, and this was another big one, was refactoring. So I had a problem that at one point, in some parts of the code, I was labeling each individual square of a square as in this thing. This is a square. In some parts of the code, 0, 0 referred to that red blob, or the top left corner of the red blob in the top left corner of the grid. But in some parts of the code, 0, 0 was the top left pixel, which on the display doesn't even have a piece in it, in fact. And it wasn't clear whether, in cases, which coordinate system I was using. So I would say I would have a pair of numbers, and it wasn't clear whether they were referring to pixels or squares. And I wanted to refactor that. It was becoming increasingly problematic. I wanted to either homogenize it or make it very clear in every context, because there were reasons for using both systems. They both had reasonable purposes in different contexts, but I needed to be able to tell which system was being used at any one point, and that required refactoring the code. Now the thing is that refactoring, when you have good unit tests, is really easy, because you can change a tiny part of your code, and if you get it wrong, your tests will fail. And in fact, and it's one of the common misconceptions actually, that people feel like they want to write new tests when they're refactoring. If you're doing pure refactoring, where all you're doing is changing the implementation, then you don't actually need new tests, because you already have, if you have a good suite of tests, you already have tests that describe the behavior of the system at all levels. So you can rearrange things and know whether you've broken anything straight away, because if you have broken something, your tests will fail. And I ended up in this awful kind of catch-22. The tests were painful to write and debug because of this coordinates problem, but I couldn't refactor it because I didn't have decent tests in place. And I got stuck in this awful situation, and that was the point at which I really thought, okay, now I know why my decision to only have acceptance tests was a really bad one. So the next one, the next area that I had problems was fast feedback. So ideally, when you're writing your code, you want to very quickly know whether it's working or not. You want fast feedback. And I didn't have that. And so what I mean is that if I'm writing decent unit level tests, then that means that I can write a really small piece of logic, a really small piece of functionality, and instead of having to run up the whole app, which particularly with iOS development can be awkward because it, depending on how you're doing your simulation, it can be quite slow. So you have to run up the app. And then typically, if you're testing a very specific piece of functionality about how a piece moves in a particular circumstance, you have to maneuver yourself into a position where you can see that happening on the screen. And that can take a while. So you can write one very small piece of logic and then you won't know if it works yet. And at that point, it becomes very tempting to just say, oh, well, I won't test it yet because that's going to be really slow. So I'll write a bunch more functionality first and then I'll test it. And if all you have is those acceptance level tests, then you can't, it's very difficult to just write a very small piece of code and then check if it works. But if you've started with a unit test, then you write the test, then you write the code, you find out instantly if it works. And it's so fast to run a unit test that you get that very fast feedback of this very small piece of logic. Does it make sense? Is it doing what it's supposed to do? So another issue that I struggled with, another area that I struggled with was edge cases. So there were a lot of edge cases. This is one of the many, many diagrams that I drew while I was writing this app. This was me trying to envisage collisions. And ironically, I have to use the solution to explain the problem. So I didn't have these diagrams initially, but without the diagrams, it's very difficult to describe the problem. Which is that if you imagine over here, you've got, if this little square here wanted to go through this channel here, what I discovered was that if I made it so that it could only go through that channel if it was exactly aligned and anything else counted as a collision, then my fat fingers could never get a piece to ever go anywhere. Because one pixel out would mean that it was colliding and it wouldn't be able to fit through the channel. So instead what I did was I defined a tolerance. I gave a kind of 5-pixel tolerance. I said that if it's 5 pixels over a boundary, it doesn't matter. And because I can detect the intent of the person with the big fat finger, I can work out they're going in that direction. They're probably aiming for that channel. That's probably what they want to do. Let's just let them do it anyway. So there's this kind of imaginary overlap that's happening. And that became quite complex to code because there were lots of different ways in which pieces could encounter obstacles. And there were lots of different scenarios. They could encounter different types of obstacle, different shapes of obstacle. They could themselves be different shapes, and they could be coming from different directions. And depending which direction they were coming from, I had to try and work out which direction they were trying to go in so that I could work out whether I was going to let them do it or not. And there were lots and lots of different edge cases and different scenarios that I had to consider. And when I finally did write all of the tests that corresponded to all of these edge cases, all of that became a lot easier to visualize and a lot easier to code. But without those unit tests, it was a lot harder. So the last one is about spikes. And this is a really interesting one. It's a little bit controversial, is whether you want tests for spikes. So let me explain what I mean by spike. I mean, people do use spikes to mean different things, but what I mean by a spike is the idea that you're experimenting. You're trying something new, and it might be a proof of concept, you might just be exploring a new technology or a new technique, and quite commonly people don't write tests for spikes because what they say is, this is not production code, we're just playing, we don't even know how it works yet, we don't need tests, it's fine. And in my case, the example was when I first started writing the pixels versus units refactor. I think maybe it was when I first had the idea of having both pixels and units. And I created the kind of dual concept. And again, I didn't write tests for it. It then became very hard to integrate into the rest of the code because it didn't have those tests. So again, I will come back to that, but spikes often end up becoming production code. Okay, so how did I fix it? The very first thing that I did was think, how can I, because first of all, I realized that I needed tests. I realized that my ability to progress was grinding to a halt, and that if I didn't stop, implement tests, change my habits, and then move forward, then it was just, the whole thing was just on a hiding to nowhere. But I also thought, why did this happen in the first place? Because in my day job, I was writing tests. And it was only in this private project that I'd managed to slip into such bad ways. And I thought, this is partly because I am accountable to no one. No one can even see what I'm doing. Nobody knows what terrible things I'm doing behind closed doors. So I need to somehow create some accountability. I need somebody to keep me honest. So I invited my friend Sal, who has spoken at Agile on the Beach a few times. She's not here this year. She doesn't actually, she's kind of retired from the industry at the moment. But she and I had already been doing some pairing. We'd already discovered that we really enjoyed pair coding together. And I said to Sal, listen, will you come and join me and be my pair on this project? And what Sal was able to provide was a steadying hand. And what I should have explained, actually, these are my two sons. So that's Felix on the left, Oscar on the right. I was at the European Testing Conference a few years ago, and everybody had GIFs, and I was jealous. So I went back to my hotel room one night and started creating my own GIFs out of videos of my sons. So you saw a couple more of them ice skating earlier, but yeah, that's Felix and Oscar. That's Felix being a good big brother. And stopping Oscar from falling over. But this is what Sal was doing for me. She was keeping me honest. She was a steadying hand. She was a second pair of eyes. She was somebody that I could consult, and she was somebody that could keep me honest, ask questions like, are you sure you want to do that? And that made a really big difference. So I also started using TDD properly. And it helped with many, many things. So the things that I've talked about already, encapsulation, single responsibility principle, when to use public and private. Because I was now writing tests at the unit level, that meant that my classes were very clearly defined. My tests were documenting my system, and they were defining the expected behavior. They were also, it was very easy to see that the tests are stating that this class should do this and only this. And also, if your tests are well written, then you can look at your tests and see the behavior of the system documented by the tests. And also, what the tests help you to do is decide what should be public and what should be private. Not everybody agrees about that. The public-private debate, some people think that it is fine to make functionality public purely for the sake of tests. So you might have a class that has a public interface that describes what that class does, and whose clients, other elements of code, are all using that public interface in order to get that class to provide its services. But the class might have some internal implementation detail that the clients never know or care about, but you want to test. And so what happens is you make those methods public so that you can test them. And whenever that happens, I always think, oh, hang on a minute though, because really I want my test to document my system. I want my test to describe what this class is capable of. And if I found myself writing a test that is checking the behavior of something that nobody else even knows about, then that I don't like that. I don't think that feels right. So what that does to me is it tells me this functionality should be in a separate class. If I care about it enough that I want to test it, then what I want to do is put it into a separate class that clearly says I am providing this functionality, which is then used by the original class. And the fact that I couldn't easily test it is actually telling me something about my design. It's telling me something about how my classes should be structured. That if this is something that's important enough to be tested, then it's important enough to live in a separate class that has that responsibility. And for me, that's one of the ways in which test really does drive design. It drives development. So that for me is a really useful gain of TDD. Another thing that I did was I started going outside in. So I always had my acceptance tests, but now what I did whenever I implemented a new feature, I would start by writing an acceptance test that would describe the behavior from the user's point of view, and then I would, and that would fail. And then I would think, okay, so what do I need to do to make it pass? Okay, so I will need some functionality that does this. Right, okay, so now I'm defining the interface of a class that does this. And then I might find that that class is saying, well, yes, but in order to make this pass, I'm going to need another utility that does this, and that might mean that I define another class. And finally, my deepest level test is going to pass, and then it's going to ripple back up to the ones above. Again, not everybody likes that technique, but for me it worked really well, the outside in. So failing acceptance tests followed immediately by failing unit tests, and it also helped me to think about how my system was designed, to think about encapsulation, to think about the single responsibility principle. Okay. So the next one was debugging. And I was now in the situation where I was refactoring. I wasn't just refactoring the code base, I was retrofitting tests into a badly tested code base. And I was also discovering bugs as I went. And this is one of the things that you might find when you're refactoring legacy code, which is effectively what I was doing, that you want to ideally get the whole system tested. And sometimes when you're gradually improving something, you might have to start by having what we call golden master tests. And you might also find that as you're moving forward, maybe the very first thing you want to do is write tests that describe bugs. So sometimes when I was fixing bugs and I still didn't have a full suite of tests in place, my priority was to write a test that described the bug. So a test that said, this thing shouldn't happen, as in the bug. And then when I fix the bug, the test will pass. So I found that extremely helpful to write tests that describe bugs. But also, eventually, I was in a situation where everything was covered by unit tests. So that made the whole debugging thing also significantly easier. Okay, so refactoring was the next one. And in order to improve my ability to refactor, again, I started writing tests. And this is where you can come across an issue with the public-private situation. So often people are so worried about whether they should make things public or not that they're absolutely resistant to making anything public purely for writing tests. But when you're in the process of refactoring, you can find, for instance, that you want to move a piece of functionality from one class to another. And you might be in the situation that I described earlier of where you've decided that actually something that is currently private should really exist in a whole other class. But while you're moving it, you might break stuff. And you won't know if you've broken stuff if you don't have tests. And the test will always help you to find out whether you've broken stuff. So in this scenario, it's a really good idea to just make the private things public temporarily in order to make them testable so that you can then move the functionality and still know that everything is still working. And I think maybe I got this one from Martin Fowler as well, actually, but it's better to break encapsulation principles to get tests in place than it is to break testing principles to get encapsulation in place. So the idea being that by making this private functionality public, you're breaking your encapsulation principles because that's no longer hidden where it should have been according to the principles of encapsulation. But you make them temporarily public so that you can test them, so that you can move them, so that finally they can be in a place where they should be, which actually probably will be public, but in a different class, so that your encapsulation still makes sense. Okay, I've got 5 minutes, I think. Is that right? No, I've got 10 minutes. Yeah, okay. So fast feedback was the other thing that I was concerned with. And in order to get fast feedback, I needed to be able to test code as soon as I had written it. And there's this nice little quote, don't wait for the racetrack to test the car. And the idea of this is that you wouldn't build a whole race car and not test it until you could get it onto the racetrack. You would be testing at least parts of it before you got to that point. So the idea here is that you do want to make sure that you're testing your individual components before you're deploying them or before you're doing a full kind of run of the whole system. But I would qualify that by saying that skeleton cars can often be driven. I'm stretching the analogy a bit there. But when I'm developing software, when I'm creating software, one of the first things I will do is create a walking skeleton. So I will create a Hello World app or solution that can be deployed and can be seen in the outside world. And I will do that before I write any functionality, because I want to know that I can deploy. I want to know that I can get it in front of my users as quickly as possible. And I did want to put that qualification in because the idea of don't wait for the racetrack to test the car suggests that maybe you're not even going to bother with a deployment pipeline. You're just going to be writing your little unit tests and testing little bits, and you're not aiming to get them in front of users as quickly as possible, which actually you should be. It's just that when you're writing one really small piece of logic, you don't want to have to deploy the whole system just to see whether it's working or not. Okay, and then edge cases, what I started doing, which I've already hinted at before, was that I was drawing them out. So TDD isn't just about writing tests. It's also about talking and thinking constantly about the code that you're writing. The tests are really just a tool that get you to that point, get you to a place where you're thinking about design. And thinking about design means talking about design. It means drawing diagrams. Diagrams are really, really useful. They're a very, very good idea. They help you to think about what's going on, and they help you to communicate with other people about what's going on. And complemented with tests, that's when you've really got the sweet spot. So for me, it was the combination of drawing the diagrams that described the edge cases and then writing the tests that went with them. One of the things that this really helped me with was to because initially, and that, to be honest, it was a while ago, so I can't remember which is which, but initially I was thinking about all of these possible scenarios, and then as I was writing the tests, I realized that some of them were equivalent. So they felt different in my head, but when I started to write the test, I realized, oh no, actually, this scenario is equivalent to this scenario. And drawing the diagrams really helped me. The combination of drawing the diagrams and writing the tests helped me to reach that conclusion. And then the last one, the spikes. People will argue, but I would suggest always write tests for spikes. One of the reasons for writing tests for spikes is that you find out how easy it is to write tests. So particularly if you're exploring a new technology or a new tool, eventually you're going to want to be able to test the code that is produced. So writing tests not only allows you to explore whether this tool is fit for your purpose, but also whether you're going to be able to test it, because that's part of whether it's fit for purpose. And also, it's so common for spikes to become production code. It's so common for people to say, oh, we're going to throw this away, and then 10 years later, there it is, still in the system, but not necessarily tested. So I did start always writing tests for spikes. Treat spikes as though they were production code. The only exception I would say is that sometimes you are experimenting with tools that are so new to you that you don't even know how to test them yet. And you might start by just kind of throwing some things down and saying, does this do what I want it to do? But your very next step should be, okay, yes, it does. So can I test it? So the story that I told was of a person who was happy and then sad, but finally happy again. Oh, that's the wrong video. Okay, I've missed a video out. That is the video of everything going wrong. And somewhere I did, oh no, I think we are going to get to it. Okay, so this is the sad part. This is when I'm being obstructed by everything getting in my way because I'm not writing tests, and you'll see poor old Oscar, he's so miserable because the toddler's got in his way. That's where I was at things going badly, but we are going to get to the happy ending. But before we get there, we probably haven't got time. So I would ask you to come up to me afterwards. If there were any of those things that you thought about at the beginning of the talk That either, if you had some reasons for being pro-TDD that I haven't covered, that you'd like to evangelize about, come and tell me, or speak to me on Twitter. And if there's anything that you had reasons against TDD that I haven't covered, I would also love to hear about those. It's a while since I've done this talk, and I haven't done it in person, so it did take slightly longer than I expected. I'm going to run through very quickly a list of conclusions. So, hopefully I've convinced you that not having tests is a false economy. You might feel like it speeds you up, but eventually it's going to slow you down. And not just not having tests, but not running tests is another one that is a common gotcha. So what you might do is write 5 very small unit tests in a row and the code that implements those tests and see those individual tests passing. Or maybe not even that, you might just be assuming they're passing. So the first thing you should do is always run those tests as soon as you've written them and implemented the code that makes them pass. See them pass. Each individual test, you need to see it pass. But also, you should be running your full suite of tests, because it's quite common that the code that you've just written made that test pass, but it's making some other test fail. And if you're not running the full suite of tests, you don't know that. And the longer you leave it, the harder it is to detect which change it was that caused the failure. The other thing is that tests facilitate refactoring. Tests make refactoring so much easier and quicker. And you should already have your tests in place before you start refactoring. Acceptance tests are not enough. But you can write new tests in response to new problems. So every time you find a bug, if it wasn't already covered by tests, write a test that expresses that bug, expresses how the code should behave without the bug. Keep everything green. So that, again, is the keep running the test, but it's slightly subtle. It's subtly different, because you could say, I'm being really good. I'm running all the tests every time I make a change. And those ones over there are red, and I know that, and that's okay. I'm going to fix that in a minute. So it's not just that you should run them, it's that you should stop when they're red, find out why they're red, why they're failing, fix what's making them failing. And then the final one is that pairing keeps you honest. So pairing is a really, really good idea. It really helps you with test-driven development and with coding in general. And that, then in brackets, 3 more slides so that I don't forget I've got 3 more slides. I'm not at the end yet. So the final slide is the happy ending. This is Oscar able to do his trampolining gymnastics without anybody getting in the way, because he's got a beautifully tested suite of software that runs and allows him to do his job. And that means we can all live happily ever after. So the last 2 slides, the first one is just a plug for my podcast. So I host a podcast called Making Tech Better. You can find it at tinyurl.com/making-tech-better. And this has been running for 5 months now. I publish a new episode every fortnight religiously at 5 a.m. British Summer Time on Tuesday mornings. I'm not literally up at 5 a.m, it's all automated. But they do come out at 5 a.m. every other Tuesday morning. And I have interviewed Kevlin Henney, Paula Paul, Jessica Kerr, Kit Collingwood, I know Corrie, Esther Derby, loads and loads and loads of really cool people. So I would, but I do recommend that you have a listen. The theme of the podcast is improving software delivery. And then finally, I work for Made Tech, and we are recruiting. So if you go to madetech.com/careers, you can find out more about that. Thank you very much for being here.